Whenever you're ready.
Am I on the camera? What? Did you use this theme too? Dude, I told you, you just go to you just go to that. It's great, dude. It's great. Would you look at that? What a nice stream, I say. Okay. Am I black screened? No. Mute? No. Okay. Welcome. That was aggressive. I'm sorry. Okay, welcome to my talk on DLL hijacking. You guys can heckle me if you want. I'll try and explain this as best I can. This was a very last minute presentation, so I didn't have time to make memes for it. Well, I got a couple, but yeah, I know. Boo. Yeah. Listen, bro, if people wanted to give me research talks, like, okay, never mind. Okay, if you don't know who I am, Enzo, look at this awesome photo. I wonder where that's from. That was a great time. Yes, social outreach. I'm the head of research, a mentorship lead guy, physical security IG. Shout out to you too, physical. I like OffSec stuff, and yeah, I like nagging people. Actually, I don't like it. It actually is very degrading, but I do it anyway. Okay, so DLL hijacking. If you guys don't know what a DLL is, I will explain that to you now. A DLL is a dynamically linked library. Okay, what is a library? A library is basically some sort of external, external container that holds functions and data that can be used by a separate application or even another DLL. So, when it comes to a library, what is dynamic linking? If you look at this nice graphic that I found on Google, there's two types. There's statically, well, I guess we can go to static, and I guess shared is dynamic here. So when you compile something dynamically, like you have an application you compile statically, you are attaching the libraries that you import into the application. That way, when you run the executable, you just have one application, all of the functions, libraries, data that you need is all compiled into one big thing. So that can be good and that can be bad. So if you're trying to have some sort of lightweight application, this is where DLLs come in. So that shared library right there, that is what the DLL will be. So basically, you run your application, and then as it's running, it's calling to the DLL, which is that library, which is its own separate entity. Save space, redundancy, stuff. Just, I mean, like if you have this right here, if you have A and B and you have the same library, it's just a waste of space when you could just call out to one copy. And it's scalability, I suppose. I think, yes, slightly less thick. We love DLLs. I think that's all I have for this slide. Okay, so what is DLL hijacking then? Okay, so like I said, when an application is running, sometimes it calls out to a DLL, like, okay, I want to call this. And that location is often hard-coded within the application itself. So it should be usually in the applications directory. That's like the most common spot. So if it cannot find a DLL where its hard-coded location is, Windows has a set thing called search order, which I will explain later on, and also you could just read the little image there, but I'll go into it later. It searches through a set list of directories, like this is set in Windows. So where we come in is we are placing our malicious DLL, which will be loaded by the application, into a spot where it can be loaded. And I'm going to explain all this in much more depth. And then it executes our DLL, and then we're poggers there. Okay, so how do we find a DLL that can be hijacked? This is like, oh, I don't know. Okay, so if you have not heard of sysinternals, please learn about sysinternals. Oh, God. This is not good. Jason, you want to fix this? Am I frozen? No, the camera's good. Sorry.
I thought what I thought. I just assumed my laptop was going to crash. It's over.
It's the Sparta laptop, guys. That's how it be.
Yeah, stop share and reshare. It might be a Zoom problem, actually.
Bill. I knew it was Bill from the start.
Sabotage. You're talking about Windows, bro? No, only Bill talks about Windows. Leak.
Many leaks.
There it is.
Oh my God. Click through the slides one time.
Okay, I'll do it. I'll go. I guess I talked. Okay, you can just absorb stream. Absorb this and think about what I said earlier, because I do not want to repeat it.
That's a nice, cute little graphic you showed.
Yeah, nice graphic. What is DLL hijacking? Read the text. Yeah, I committed like severe wall of text later in this presentation, so absorb the pictures now. Okay, and look where we are again. Yes. Okay, so back to sysinternals. If you haven't heard of sysinternals, basically some great tools for Windows. So the one we're going to be using today is called Process Monitor, or Procmon. And you should probably use this during IRSec, maybe. So I'll show you a screenshot on the next slide. We have some general filter criteria. This, you don't have to follow this by law. This is just what I found when I was looking this stuff up. So you search for result, and you'll see this in the screenshot. Result, name not found, so that means the DLL is not found. The operation is create file. I feel like just everywhere I looked, I don't exactly know why create file here, but create file. And of course, path contains .dll. You're looking for DLLs that are not found. Let's see. Or I put some resources on the last slide. There are automated tools to help you find DLLs that you can hijack. And let's take a gander at this nice photo right here. Okay, so you see here, SVC hosts. It's trying to find this DLL right here, WPTS extensions.dll. And see, they started the service. This is running over here. And as you see, it's going down a little list where it can try and find this DLL here. I'll go into search order next slide. But generally, like I said, result, name not found, DLL in the path, create file, stuff like that. Okay, I think I messed up my slides a little bit. They're a little disorganized. Okay, so there are three main things when people talk about DLL hijacking. So the first one is DLL search order attack. That's what I'm talking about today. That's the main type. And then I'll go into Ghost / Phantom and side loading at the end. God, this is so disorganized. You could tell I made this really late or early in the morning. Okay, so what I was talking about, search order. So as I described before, search order is the set order of directories that Windows searches when it cannot find a DLL. So what is the default Windows search order? So it starts up where the application is loaded. So this is where your application lies. It looks inside the same folder that it is running. That's the start, that's the main. The next is the system directory, system32, something like that. Next one is the 16-bit system directory. I don't recall the actual path to that one off the top of my head. Fourth, Windows. John, do you know that by any chance? The 16-bit system directory. You know the path to that one? I don't recall.
It's programs.
Just straight programs.
It depends on if you have a 32 or 64-bit operating system installed.
Interesting.
If you do, like it's one. If you don't, it's the other.
Okay. Yes, programs then. Yeah, the 60. Who uses it? Why are you coding? Okay. Anyway, the fourth one, Windows directory, C/Windows. It'll check in there for that sort of thing. 5 is your current working directory, so where you are right now. That's a good one that we should look out for. And then the sixth one, the last thing it checks, is in the path variable. So if you don't know what the path variable is, basically. It's a sort of environment variable you can change. It basically, is there a question, Loudon?
Don't we have to set that if you install Python?
Yes, yes.
That's
yes. So, okay, yeah, well, that's a good example. So when you're installing Python, in order to run the Python command from any point in CMD, you need to add the Python directory to your path variable. Thank you, Loudon. So it can run. So it checks all the directories that are listed in your current path. Awesome. That was very helpful. Okay, so, damn, did I just repeat slides like crazy? Okay, anyway, yeah, so that's the order. So usually what happens is you're not going to have write access to like the top one. So the higher that you can go with write access to, the better, because this is the order. So if the DLL, the actual legitimate DLL exists in 6, the path variable or the current working directory, if you can inject inside 4, it will load your DLL before it gets to the actual DLL or something of that matter. Wherever you have write access to is the goal. Okay, so there are a couple ways to mess with search order. So the first one is this registry key. I'm not going to read that out loud, but safe DLL search mode. So basically it's just a 0 to a, or change it to a 0. 1 is safe DLL search mode is enabled. So you change it to a 0 to disable, and then it updates to a more insecure list. So basically, if you remember from the last slide, the current working directory was all the way here at the bottom. Like that's where you are. So if you update this, change the modifier, it shifts to the second position. So it goes to that one directory where the application is, and then it checks the current directory next. So that might be something worth looking into if you're messing about with this stuff. And then the rest of it is the same down there. Okay, another thing, the load library EX function call is a Windows call. You can load it with this flag called load with altered search path. It does the exact same thing, moves current directory to there. Another thing, is this in the way? Yes. Okay, messing with the search order, load library search flags. Oh wait, yes. So this is a different, separate thing. This is all on MSDN, by the way. You can read about this stuff. I'm just going very basics on this. So what you can do, if you're really modifying this stuff, is you can set your own custom search order with these two functions right here. I really should have thrown a screenshot up. But the updated search order list, after you create your own custom search order, is the application directory, of course, that's the first one always. Then it will check all of the paths that you add using the function above, and then it'll check system32. So if you mess around with that, it might be worth doing, but you have to have some pretty strong access to work around with this stuff, so you might just want to do the normal. Okay. So once you've injected your DLL, you can generate your DLL or write your DLL to do anything. You can do a reverse shell, you can do something as simple as calc, blah, 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 blah. Whatever you want to do once the library is loaded by the application. Okay, so this sounds like an amazing attack, right guys? It sounds perfect and awesome and it works every time. No, this is horrible sometimes. If you can't get it working, I'll go into some stuff. So crashes the application a lot if it's like, I guess if they don't have any, or if they do have restrictions on like, or I'll go into signed DLLs later. If it sees that it's unsigned or if it doesn't recognize it, then application will most likely crash, your DLL thing won't work. And also, when I was writing a demo for this, which I now do not have, I bricked my Windows VMs like 4 times doing this, so that's why I don't have my demo anymore. Yeah, I kept bricking my VM, so I had snapshots, but it's just it's a hassle and a half.
Oh, it's a hassle to click one button. Oh
Listen,
God, so
okay, you make the demo then. Okay, so basically, when I was messing about with this, I was trying to trick the DLL in system32, and it's unsigned. And Windows got really angry and then just bricked itself. So what you have to do is go into safe mode and then delete the DLL. Otherwise, it'll keep bricking. or blue screening rather. Okay, well, say you have an application that it does work on. Excuse me. Listen, bro, I've been talking for a while. I know, no more take twos. Have a good one, Bradley. If it does work, it's quite loud. AV usually has an easy time tracing it back to the DLL. Also, devs can do this thing where they can remove search order from execution. So they'll hard code the address and then prevent search order from occurring. So that's a thing. And also, there's this thing called software restriction policies that you can enable. I don't know exactly how to configure it, but you can make it so only signed DLLs will be loaded. If you don't know what a signed DLL is, basically there's some sort of authority that verifies that this is a legitimate DLL, it is valid, it is not malicious, and anything else is an unsigned DLL. People can attack this. They can generate their own signing things, but yeah. Okay, subtypes. Look at this is like the one meme that I got. It's pretty bad too. Okay, subtype. So this ghost phantom DLL hijacking is literally the same thing. It is the same thing as search order. It is just a focus on outdated or legacy DLLs. So sometimes an application will load and call a DLL that is really outdated and not necessary at all, but it still calls it, and that's why it's called a ghost DLL hijacking. I just thought I'd note that quickly, because you might see that if you're researching this stuff. Luckily, I'm on the last slide because I'm about to die again. I know, I'm totally fine. Okay, DLL sideloading. This is like a whole different talk that you can go into. But I'll just give you the basics quickly. So instead of using search order, this thing called Windows side by side is used. It's a whole directory. Basically what this thing is, it manages duplicate versions of DLL. This is usually for updating purposes. So if a dev comes in, they say, we have this updated DLL, but it's got the same name. They put it in there, and then they have this thing in the executables. This is metadata. They're called manifests. And basically what these manifests do is tell which DLL to load. So if you can find a way to edit the manifests, what do you call it? Manifests data, there is no validation besides the manifest data. So if you can attack the manifest data and say that my DLL is the one to be loaded with the same name, then that's a whole validated execution, like this will work. So if you look at the nice photo over here, I don't know if you guys can see that or not, but basically they have, you know, the malicious DLL, they put it in there, they edit the manifest data, and then it will load that DLL instead. All right, so throw some resources on there. Thank you for listening. Any questions? Any heckles? Anything? Okay, yes. So yes. Listen, bro, if I get my demo working, I'll present it next week. Shut up. Shut up. My malware's all broken. What's your question?
What's your take on the consequences of the Industrial Revolution?
This is a whole essay question. I don't know if I can answer it right now. Yes, any other heckle questions? Okay, thank you guys for listening to my talk. I appreciate it. Woo! Yes, thank you, thank you.